So now I want to show my code in actual FPGA demonstration. Okay. So I've already finished the generate bit stream, and I already pushed my bit stream on my FPGA, which is here. Yeah. So I want to choose the comparator module first. Okay. So for here, the first 4 switch is control is to use to input the first number A. So this is A, this is B, and this is the old instruction code from Lab2, the 4-bit instruction code. I think this one is carry in, and this one is the display mode. Display mode can show can make the segment to show the input or the output. Okay, so this one is the new instruction code. It is in Lab3. So when this switch is used to control the comparator. So when this switch is on, it is now comparator mode. You can see this LED is on, which means these two input number is equal. So the input number is A is 0, no switch is on. B is also 0, no switch is on. So they are actually equal. So this LED is on, and the 7-segment display shows 0, which is a 2 number volume. And now I push this switch. Okay, so now A is 1. Now the LED is off, so which means this 2 is not equal. As you know, the 1 is not equal to 0, and the larger one, which is 1, is displayed on the 7-segment display. And I change B to 7. Yeah, no, it's 15. So 7. They're not equal. This LED is off, and the display shows a larger number, which is 7. Now I want to change the value of A to 15. Yeah, so it's not equal, and the larger number of 15 is shown on the 7-segment display. Yeah, so this is a comparator. Now I want to show my VGA display module. Yeah, you can see the VGA display module is already on. I use this switch to control the color of the VGA display. So you can see I actually use one switch on multiple purposes. You can see here when this switch 000, so the RGB this kind of color is all on, so the screen now is white. Yeah, I change one switch, it's right. Change another switch, it's blue now. And I set switch to 2, it's yellow. I set switch to 3. I can set the switch to 4. And this is 5. This is 6. This is 7, which is black, which means no color is on. Yeah, that's my 7-segment. No, that's my VGA control. Okay, that is what the content of my Lab3.
好，我在录了，我在录了。So this is our Lab3 code for the. Here is the system top. It includes 3 modules. The first one is decoder, second one is ALU, and the third one is VGA display. For Lab3, we added 2 new modules. The first one is comparator, which is included in ALU, and second one is VGA. So the comparator here. Yeah. Let's see. So it's like this. it can choose whether they are equal or not, and if they are not equal, it will choose a larger number on the 7-segment display. So you can see in the ALU, I add a new operation code, 1 bit. So when this bit is on, the outcome of a comparator will be output to the sum of ALU and be displayed by the decoder. And if it's off, it will output the normal result of ALU, and also add another output, LOR, which means larger or not. And so this will get an output from 1 bit output from a comparator, and this is connected to an LED. So when the LED is on, which means they are equal. When it's off, which means they are not equal. And now you can see the 7-segment display to find out which number is bigger. So this part is the VGA part. So it's your turn.
So to build a VGA, we first build the clock generator, which is showing in this part. What does it do is basically counting the numbers using sequential logic. And then we build the horizontal counter and vertical counter. And it is shown here. And then using these 3 parts, we finally build the top mode. It is showing here. And we finally using a mode called OPE to change the color. Because without the mode, we could basically see the white screen. And with the options available, we could display more than white. So for example, the red, the yellow, and green.
In total, we can display 8 colors from white to red, green, blue, black. So it's just a selection statement on axis. It can choose it from 0, from off, and on. So by combining the different colors from RGB, it can choose 8 different colors. So this is an interesting but very simple part of our code.
Yeah, that's it. Thank you.
Thank you.